Let's imagine a situation where we have a method that takes in several parameters. These parameters might represent different things that the method does. The method is divided into parts, and each part is executed based on the value of a parameter. In cases like this, what we should do is create a new method for each possible value of the parameter. That's where the replace parameter with explicit methods refactoring technique can help. This technique is specifically useful when a method has multiple parameters that determine its behavior, and managing different combinations of parameter values becomes challenging. The main idea behind this technique is to make separate methods for each possible combination of parameter values. This makes the code easier to read, understand, and maintain. Hello guys, welcome again. In this lecture, we'll be focusing on the replace parameter with explicit methods technique. This technique falls under the method refactoring category in our refactoring diagram. Okay, let's dive deeper into this technique with some examples. Consider a scenario where we have a method called performMathOperation that takes three parameters: operation, number 1, and number 2. The behavior of this method depends on the value of the operation parameter. To make the code more explicit and easier to understand, we can replace the parameter with separate methods. Okay, we'll make three methods: add, subtract, and multiply. Each method will perform a specific math operation. As you can see, we can simply call the method that matches the math operation we need. Alright, let's consider another example. Here, we have a method called calculateDiscount that calculates the discount based on the customer type. The customer type parameter in this method determines the discount calculation logic. As the number of customer types increases, the method becomes more complex and harder to maintain. To simplify the code, we can use the replace parameter with explicit methods refactoring. We'll create separate methods for each customer type. Now, instead of calling calculateDiscount with the customer type parameter, we can directly call the appropriate method based on the customer type. By using explicit methods, the code becomes more readable and it's easier to understand the discount calculation logic for each customer type. Alright, it's important to understand that if a method is rarely changed and doesn't need new variations, we don't need to replace a parameter with explicit methods. For example, let's consider the copyFile method. The copyFile method has three parameters. The override parameter determines whether an existing file at the destination location should be overwritten or not. In this case, since the value of the override parameter will always be either true or false and won't be changed, it's not necessary to replace the override parameter with explicit methods. Okay, done. See you soon.